Hey guys, welcome to my channel. This is Deepak. This is our next video in the playlist of NFRs. Last time we discussed on performance. Today we would be discussing on scalability. So let's start. So scalability, one thing that is very much important that you guys need to understand is scalability means there are two things. Always the scalability, that first thing whenever we heard the term scalability, the thing that comes into our mind is that is a spike and that is a growing thing. That is a wrong conception basically. So scalability means it is growing and again it is falling, like upscaling and downscaling. That is first thing. Second thing, it can be a spike or it can be gradual. These are the two things that we need to understand, and our system should be in such a position where it should be able to handle the spike as well as it should be able to handle the gradual increase or decrease of a traffic first, and second thing, it should be able to handle this upscaling as well as downscaling. So, starting with that, scalability has two things. First is upscaling and downscaling. Upscaling, as you can see in this particular diagram, let's say I have my started my YouTube channel and I am posting a YouTube video. So then, in that case, let's say initially because my channel is new, let's say I'm getting 1,000 views. Later, the time as the time passes, my views grows from 1,000 to 100,000. Again, similarly, you can see in the downscaling format, you can assume like, okay, this is a spike and then this is going down. So in this thing, you can take an example of an IPL match. Let's say people are there on Geo Hotstar and the IPL match is started. Dhoni is coming for batting. People are excited. Suddenly the view spikes, and then later, as soon as Dhoni's wicket goes down, the views drop. That is a spike, that is upscaling, and that is downscaling. That is a spike that we are talking about. Instant rise and instant fall. Next, we would be discussing on types of scaling. So there are two things like vertical scalability and horizontal. Like these are not types basically, but after the scaling happens, how are we going to tackle that problem? We are going to tackle it via vertical scalability and horizontal scalability. So when we are saying vertical scalability, what does that mean? It means like, okay, you have a server and there in that case, you are increasing the resources. Let's take this particular example. I am having a server. Initially, my server configuration was 4 GB of a RAM, 2 core of a CPU, and 100 GB of a disk. Now I have done a vertical scalability. Means like I have increased the resources, but still I have in the production only one server, but it is like now 8 GB of a RAM, 4 core of a CPU, and 200 GB of a disk. Now, when generally this thing is done, this is done in the cases where like we are preempting the traffic. We know okay, this traffic is going to come and this is going to be there for a longer time in our system. Let's say because now my initially was my company was a startup and so I was having less people, less users using that particular system. Slowly and steadily now I can see like there is a steady rise, and because of that now this is the bare minimum traffic that I am going to get at any cost, and that's the reason I'm doing a vertical scaling. And but the thing is like okay, this can't go infinity. Why? Because you can't increase your RAM from 4 GB to 400 GB, let's say, or you can't increase your disk space from 100 GB to let's say 100 petabytes. This is not feasible. That's the reason. And again, like other than this, there are multiple different reasons like sudden spikes and cost optimization and other things. That's the reason the new term that arrived is horizontal scalability. This horizontal scalability means you see, I have two servers initially, let's say in the production, having a configuration of 4 GB of a RAM, 2 core of a CPU, and 100 GB of a disk. Now I have splitted that and I have increased, I have scaled my servers horizontally. That is, I have added two more servers now. So still, when I have added the two servers, the configuration of those two servers are same. Of those two new servers are same. That is like 4 GB of RAM, 2 core, and 100 GB. Overall, if you see now the configuration has increased. Earlier, if like two servers was having 4 GB, now four servers we are having 8 GB, which is equivalent to this. But what I have done is I have kept the resources in every single server same, but I have just scaled the servers. Now, why this horizontal scaling is required? This is required like there is an auto scaling policy that is generally there, where like you are having a pods and let's say there is certain spike or certain events are there and more users you are preempting. At that time you just don't increase the resources of your pods, but what you do is like when as and when the traffic increases we scale the servers, and as and when the traffic decreases we descale the servers. Basically we bring it to its original shape or original cluster size. This is what horizontal scaling helps in. Basically like every time without disturbing your traffic, what you're doing is for the new traffic you're scaling the new server, you're scaling down. This helps in firstly in the cost optimization, and the second benefit is let's say if I'm just focusing on the vertical scaling and I have increased enormously my resources of a particular server, what if that server crashes? All of my requests would go down. In this case, most of the servers are there. If certain pods, even if crashes, the other requests are fulfilled. So first example that I've given you, or first use case that I've given you, is basically if you're not preempting the servers, second, without disturbing your existing traffic, and third, not having a single reliability on one single server but scaling it and scaling down, and fourth reason is the cost optimization. That's the reason horizontal scalability comes into the picture. So now this is the technique that we have discussed. How are we going to tackle the scalability problems? Now, which are the segments or categorization where scalability actually comes? We would be discussing those. So one thing that you need to understand is, so let me just clear this thing. Okay. So you might have heard till now, whenever we were speaking about the scalability or anyone speaks about the scalability, they're just saying like, hey, increasing the traffic or increasing the request per seconds and this and that. But it is just a tip of an iceberg, I would say, because scalability has penetrated in different segments. There are various different categorization, and when we are seeing our system supports, our system is scalable, our system supports scalability, it should be able to suffice all these different kind of a scalability categorization or a parameters that we would be discussing just now. The user scalability. Now in the user scalability, again, like it is an increase and decrease. Every scalability, increase, decrease, spike and gradual. Just remember that thing. User scalability, it is number of users on the platform that is increasing. You need to understand that the number of users on the platform are increasing. Again, it can be a spike, it can be gradual, but the users on your platform is increasing. So let's say today there was only like one user who is using my platform. Tomorrow there can be multiple such users who are using my platform. So this is what I am calling it as the user scalability. So when the user is increasing, the traffic is increasing. When the user is decreasing, the traffic is decreasing. This is what user scalability is. To take an example of user scalability, again, we can take an example. Like, let's say I have started a new YouTube channel. I have very less users. I have very less subscribers. As and when my channel would grow, the subscribers would grow, the user would grow. But there is a startup, and the startup, the platform they have launched, let's say it is a ticket booking, and initially only few people are using. There is no marketing, there is no nothing. As and when the platform sparks, there is more marketing, there is more word of mouth publicity, more users start using that platform, more users start coming, more traffic start coming. So this is what the user scalability is. Now where does it actually put the pressure on? So most of the services, most of the companies have the user service, authentication service. The more users are coming, they have to do the login, log out, authentication, authorization, validation, all those things are there. So these are the places where the stress increases in the infrastructure. Again, like there is a load balancers. There is a, if the systems are made like a stateful system, then the managing the session, that again becomes the problematic things. Again, a lot of DB calls we need to do for authentication, authorization stuff. That's the reason, like these are the segments where the pressure actually rises in. And how to achieve that? Try to make your system as much stateless as possible. Have more read replicas, so that like for the same redundant data, the request should go to your cache, should go to your read replicas rather than going to your master databases. Have a Kubernetes auto scaling, because these are the services which is going to be under the stretch, and because of that, if more users are coming, more requests for authentication and user service. So auto scaling of this particular service is very much important. This is about the user scaling. Traffic scalability is you have the same users, but the traffic is increasing enormously. So let's say I was having one user, and one user is sitting one request. So now there is one request per second. Okay. Now with the same user, I can have 10 requests, and it can be 10 requests per second. So you see the user base is same, but the number of requests has increased. This is called a traffic scalability. To give you a better example of this thing, assume a use case where there is a Geo Hotstar platform, which is a live streaming platform. And here in this case, let's say there are 4 services that is there. Firstly, let's say it is match feed. This is the first. Second, it is about like, let's say movie searching, because again it is a live streaming platform. Third, it is about, let's say, movie watching. Let's take these 3 examples. Now assume, and again, like this is a hypothetical example, there is a match going on, and let's say I am having 100,000 users who is watching match, correct? Now no one is stopping them for going onto this particular URLs or hitting this particular URL. So let's say if I am having 100,000 users, they are all watching match, I have 100,000 requests per second. Okay. Now let's say if these users start hitting these 3 APIs, so now if they are hitting 3 APIs, Suddenly the traffic rose to 300,000 requests per second. So traffic scalability, what matters is like there can be hit. It doesn't matter whether it is for that particular flow or to different flow. It doesn't matter whether the same user or multiple user. It doesn't matter. The thing that matters is, okay, I am supporting these different flows. Traffic can come at any time to these different areas, and traffic can come and I should be able to handle this traffic. That is what my utmost priority is. Basically, I don't care whether it is coming from the same user or multiple different users. The only thing that matters is like whether I'm able to serve that particular traffic, whether my system is performant enough, be it latency, be it throughput, be it security, whatnot. Already about the performance I've discussed in my previous video, please you watch that. So whether I'm able to serve it, it can be concurrent request, it can be delayed request, it doesn't matter. At that particular moment, if I am getting those many number of requests, whether my system is performant enough or not, that is what matters in terms of traffic scalability. So you see same number of users causing increasing or decreasing in the particular traffic. Again, like, don't need to increase in user for traffic increase. Traffic can increase but the user can stay the same. Here where the pressure can majorly come on, the pressure can come on the pods, the internal resources. It can be hitting a more CPU, more RAM, more disk, more network bandwidth can be utilized in this particular case. The problem would be majorly on the rate limiting, because now we have to do the rate limiting, plus the important thing which I haven't mentioned here is load balancing. Because now as and when I am getting more and more traffic, I should be able to manage the load properly and direct and dissect the request into every single pods based on like how that pod is performing. So load balancing and rate limiting are also the places where the pressure can come on. How would I be achieving that? Majorly using, let's say, caching, because if there is some static data, I should be able to cache and return the response, so that like my system is much more performant, less pressure on my resources I am getting. Second thing, I should be using the CDNs. In that particular cases, I should be anticipating the traffic and bombing up my server, so that like more and more pods are readily available to handle the traffic, to have less spin up time. Then asynchronous communication, how you code. If more and more asynchronous communications, queuing mechanisms you are using, less synchronous call, less wait time, less pressure on your CPU and resources, less thread blockage, all those things matters. So this is how we would be handling traffic scalability. Feature scalability, let's take an example. Basically from an Amazon perspective, it was just a e-commerce platform where customer was able to search like kind of a carting system and place an order and order system. Now Amazon has grown and it had added Amazon Pay, Amazon Prime, Amazon Mini, and all different features it has added. So it can be different service, it can be the same service. Again, when I'm saying feature scalability, it doesn't mean like there is a whole system in that multiple microservices, multiple different features, or one single service and having multiple features. So these are the things when I'm saying about the feature scalability. Your system for the user, it is like a system is there and I am getting these more additional features. Again, when I'm saying feature scalability, it can be external or it can be internal. These features can be external. When I'm saying external features, it means like a user is able to, for example, in a YouTube, initially you were just able to see the search for the particular video and watch that particular video. Now the shorts has taken the place. Then the user analytics, the person who is uploading the video, he can see the analytics. So these are certain features. These are an external features which user is using it. But most of the time there are, and like not most of the times, but considerable amount of the time, there are these internal features which we are not actually building it for the user, but we are building it for our system to be performant enough. This is called an internal features. So which user is not using, but it helps us in enhancing our system. So this is what feature scalability is. So it can be like one system leads to multiple features which can be dissected into two things, either multiple microservices, it depends on the features, or it can depend on same service, more feature. This is again truly possible. So this is what feature scalability means. Now where does it put pressures on? So let's say you have designed your system and now during doing a designing HLD and LLD you were doing, now you need to, let's say, add more features. Now in that case, let's say you say like, hey, my design doesn't support this particular kind of a thing. Or let's say you have designed a database schema and let's say you were supporting 4 to 5 features and now you got a request and you need to scale your system for having 10 more features. Now in that case, you can't say like, hey, I can't scale my database schema, or this database schema is not suitable for this particular feature. This is what a designer primarily needs to understand whenever he's designing a system. Designing is always considering scalability in the mind. Like this kind of feature can come in future, and my system should be able to handle this particular thing. Again, when you are designing, you have to consider the scalability. When you're coding, you should not. When you're doing a coding, you should be focusing on KISS and Yagni principle, where you should be adding bare minimum code. What is needed in the future, at that time you can add the code, but always there should be the scope in your design which should be able to accommodate those future feature requirements. If let's say suddenly I am getting a call from my manager or from my CTO saying like, hey Deepak, we need to add these new features. If I am giving this answer to him saying like, hey, my system doesn't support or we can't add this particular thing and I need to scrap what I have developed till now and I need to redesign the system, then that is going to be the big blunder. So always it is the responsibility of a designer. When he is designing a system, he should be considering this feature scalability that can come in future, and he should design that system. He should design the DB schema in that particular format. So what does data scalability means? So now when I'm saying about the data scalability has two aspects to it. One is when the data is in transit and when the data has already been saved in some kind of a storage mechanism. What do you mean by like data is in transit? So you can see these 2 points, like data in transit and data which is in store. When I'm saying data in transit, what does that mean? Let's take an example of an Instagram. So let's say in an Instagram has this stat setting like, okay, on every hour I would be getting 10 GB of video upload request. We generally shoot the reels and we upload it on the Instagram. So it has this stats like, okay, on every 1 hour I should be getting the upload request of the reels, which is summing up to 10 GB of data. Suddenly, let's say there is an event that is happening. Let's say there is a war that is happening somewhere, or some World Cup match is there, and India is, let's say, winning, and what all thing is happening. That is the moment where people are going to shoot much more reels and going to have much more upload requests to the Instagram. That is the moment where, when Instagram is saying for 1 hour, we are suspecting 1 hour is equal to 10 GB. Now suddenly they are getting 1 hour 100 GB, 100 GB of data. So this is what the data pipeline should be able to handle. They should anticipate like, hey, this is the event that is going to happen. People can upload more requests at that is the time. How can I handle this many data? How my data pipeline should be able to handle this much huge amount of data? How my persistent systems is going to work? How am I going to dump the data? All those things matters a lot. So this is what the data in transit scalability means. What does data in store means? So let's say 2 examples we can take. So first thing is, let's say taking an example of Paytm or Razorpay. In that case, initially when they started having these UPI transactions, and they are keeping these UPI transactions in their database. Let's say they are using a Postgres database. For an example, I do not know what tech stack they are using, but let's say Postgres database is there, and initially, let's say a couple of months are there, the everyday basis the transaction is happening. Let's say per day there is like, let's say 1,000 transactions. Just to give an hypothetical example, transactions per day. This is transactions per day. Okay, so let's say after 30 days or after 60 days, let's say after 30 days it is like 30,000. And let's say after 3 months it is like, let's say 90,000. It is like, again, it feels like, okay, very low data, nothing more. But as and where, let's say, a favorability of Razorpay or a Paytm is growing, and as and when people are doing more and more transactions, a lot of factors are there. Because of that, now there is a spike, there is an increase. Again, like the time is passing. So let's say after 1 year, if we start seeing, because of a lot of factors, there can be the possibility now my database consists of 100,000 transactions. And let's say after 1 more 6 months, I can see there is like 1 billion transactions in my database. So now you see, like, there, that is the same database. Let's say there is a table called transaction table, and in this transaction table, initially there was 1,000 transactions. Now after a couple of years, there is 1 billion transaction. So just imagine the amount of gravity. And again, 1 billion is nothing. Like, it is like very simple number. I'm just taking a hypothetical example. So now you see, if you want to showcase the transaction history and anything to the customer, how are you going to do that? Like fetching the entry from your like 1,000 rows, and again like fetching the entries from 1 billion rows, like that is the enormous difference. It can like slow down your system. The performance is going to get impacted. Your security is going to get impacted. There is a lot of pressure going to be on the database, and all those things that is going to happen. Latency, throughput. So this is the thing that can happen. Let's take another example. Initially, when YouTube started, at that time, let's say few people were uploading the videos. There were less mobile cameras, less people were interested. It was having, let's say, 100 GB. Again, a hypothetical example, 100 GB of YouTube videos Google was saving. Now let's say after a lot of years, today that 100 GB might have grown to petabytes or even more than that. So all those videos YouTube need to persist. So the size of data that you are seeing, those data are getting dumped into the database or in some kind of a storage. Database is like data store where you are storing the data. It can be your MySQL or it can be anything. But this is the huge amount of data that is going to get add on, because data is today's gold. Everyone is going towards the data. Data is going to get increased, and it is our responsibility to maintain that data, to use that data optimally without impacting the performance of a system. This is what data scalability is. Now, how to achieve that? There are a lot of mechanisms, like we can go with partitioning, we can go with sharding, we can go with read replicas, we can go with master slave architectures. If I'm getting too many requests, I should redirect the request to my read and less request to my master. If it is a high write throughput system, I should use the proper database. I can maybe go for Cassandra or ScyllaDB. Or else if it is more transactional based, I should go with MySQL, Postgres. There should be a proper purging policy. I should be having a cold storage and a hot storage. I should be purging the data after certain amount of time to my blob storage. I should be having like change data capture log, so that like I can train the data. At the same time, I should be having a proper security mechanisms. My query should be optimized. I should not just involve in like too many joins, and the database schema is pathetic where like I'm just going with too much denormalization or too much normalization. Everything should be considered when a database is getting designed. So this is what data scalability, the problems, and the how to achieve that I have mentioned. What does team scalability means? Team scalability means consider a use case where multiple teams are working on the same code base. As and when your features are increasing, again, when we were discussing about the feature scalability, we have seen like there can be multiple microservices or multiple features, or one single service can have multiple features. In that, a team, if the feature is scaling, multiple microservices, multiple teams can work on that. Or else what you can think is like, okay, same service, multiple features, more and more developers are getting added, more and more testers are getting added to your team. At that time, your code base is no more your single code base where it is like being worked in the single group, but it can happen like multiple teams are working, where like multiple developers from different time zones, from different environments, they are working. Different knowledge basis, having an intern is also working, and then like let's say 15 years experience person is also working on that. All these things, all these factors are not under your control. What is going to be impact with that? Let's say multiple services, multiple team service interactions, code scalability, code maintainability, the way they write the code, the way we write the code, that is going to be totally different. The design patterns that they are using, that is going to be different. When multiple people are working on the same code base and we are raising a pull request, at that time the GitHub, the more and more the resolve conflicts are going to get happen. The code base is increasing, the team is increasing. At that time, there is a possibility of having a regression. Understanding of a code, like one person has written a particular format of a code, another person should be able to understand. All these things should be considered because the team is scaling. How are we going to achieve this particular thing? So here in this case, if we want to achieve, it should be we should try as much independent code base as possible. Again, like every time it is not possible. If it is possible, let's do that. Have multiple different repos for multiple different services, so that there should be less less conflicts when we are raising a GitHub pull request. Less transition of a team on working on that particular code base, having a proper technical design documentation, how the system has evolved, what all things or the design has been considered, what all trade-offs had been taken when we are designing that particular feature. There should be having a standard coding pattern or coding template across the system, so that like everyone should be following that particular thing. There should be the sonar cube, the check marks, who is going to check the code quality, and all those things. All those things are very much important. Let's discuss on infra scalability. So now when the request is hitting, when the user base is increasing, when the traffic is increasing, when the code base is increasing, everything is increasing, we need to scale our infra. At that time, it is very much important for us to understand in terms of infra scalability, like, okay, there is now CI/CD pipeline, there is new pods are getting arrived, how we should manage that particular pods, how if you're doing a vertical scalability or horizontal scalability, if you're adding more database nodes, how we should handle that. If let's say you are now doing a read replicas or copying that particular data into different zones or different regions into the cloud, how should we manage the synchronization of that? If you are using a data center, how should we ensure like, okay, that data center, because that is again going to be part of our infra. So the more data centers we are having, more S3 we are using, how we should ensure like, okay, there is the electricity that is present, the data should not go down, the server, the databases should not go down. Because the infra is going to scale, more and more operational efforts are going to come, be it a server, be it a soft, be it a load balancer, be it your ingress egress, be it your database level. be it your network IC, whatever things are there, infra scalability whenever is happening, a lot of operation cost is going to get added, a lot of maintenance work is going to get added, and that is something that should be understood. And this is unavoidable. If your user is increasing, if your traffic is increasing, if your business is growing, your infra is going to grow. And then your infra is going to grow, it is going to scale. At that time, you need to understand like how you are going to manage that. Again, one thing I wanted to say is like, let's say there is an auto scaling policy that is there in Kubernetes, where your infrastructure, your pods are scaling and then your pods are scaling down. So graceful degradation of the pods are also very much important. So let's say there is a pod who is serving a request. You can't say like, okay, because I am having less loads, I am going to abruptly kill that particular pod. No, you have to wait for that pods to go down. You have to see like, okay, now my requests are smoothing down, so I should not slowly kill my servers. Again, like infra scalability, we need to manage like with zero downtime. How should we apply different deployment strategy like zero, blue green, or canary deployment, or different kinds of a thing. So a lot of efforts, lot of brainstorming goes in infra scalability, managing the upscaling and downscaling. Then we would be discussing the final thing is cost scalability. When all these things are happening, do you think like the cost is not going to scale? Cost is going to scale enormously. And this is something which is managed closely by the business, because at the end of the day, business is the one who is going to spend the money from their pocket. So for them, it is important like it is my priority, my business should grow, my customer should be happy. But at that time, I also need to have this matrix like how my cost is scaling and how should I have a control on that particular thing. So business is focused more on the cost part, keeping the customers happy, keeping the business growing. And these stats needs to be managed properly by a system designer, by a system architect, because he is the one who is going to tell like, hey boss, this is a new infrastructure, that is something I need for serving this particular request, or serving this particular feature, or this is the new set of a team that I want. All those things, like just cost is not going to increase because your infra is scaling. It is going to increase because your code base is increasing, your feature is increasing, so your team size is also increasing. You are purchasing new offices in the different regions because there is like work from office policy, new people are going to there. So all those things has to be considered when we are considering the cost scalability. Some things an architect is going to consider when it comes for a software development, something a DevOps team is going to consider, something a business or a PMs or the management is going to consider. All those things together focus on the cost scalability. How can we, and again, like the one more important that I miss is like we have to consider whether the cost is increasing linearly or exponentially. That is very much important factor. Linear increase is okay. This is what I'm saying, linear increase, and this is what I'm saying like, okay, it is exponentially increasing, and then again dropping, exponentially increasing, and then again dropping, and then again exponentially increasing. So this is something this should not happen. And the second thing is, let's say I'm okay if my cost is increasing, but whether that every single penny that I'm spending, whether it is gaining me something in return, whether my revenue is increasing, whether my profit is increasing, this is all very much important thing. If you remember like my videos in the system designing, I have said like whenever you are designing a system, you have to consider business as your priority, you have to consider your customer satisfaction as your priority, you have to consider cost as your priority. You just can't go ahead and draw those particular funny boxes and you can say, hey, my system is designed. It doesn't work like that. You have to consider all these things, and then only you should be, as a system designer, as an architect, you have to consider these things. Are you going to ask these questions in an interview? Maybe, maybe not. But when you are actually designing a live system, you have to consider all these parameters. Every single penny that company is going to spend, it is going to be on your call, because company trusts you. You are an architect, you are a designer, so you have to also consider like whether I am investing this thing, whether it is worth for my company, whether it is worth for the profitability of my company. How to achieve that? Try to be cost optimization, try to do resource utilization properly. Again, in one of my previous video I have said is like resource utilization is very much important. NFR, again we would be discussing that in our NFR list, where we have to squeeze every single computation power from our CPU, every single memory from our RAM. We have to squeeze that properly. We can't just say like, okay, if my server is even supporting, let's say capable of supporting 20,000 requests, but I'm just scaling my pods. Scaling a pod, you have to spend the money on that resources. So you have to think that properly. If like 2 to 3 engineers can do this particular problem, having a team of let's say 10 engineers, I need to spend the cost. Again, like companies, you can see like companies are doing cost cutting. They are reducing the engineers. They are focusing more on more AI, because that is like gaining them more benefit as compared to spending the money on an engineers. So all those things have to be considered. How can I optimize the cost and gain much more more power out of it and try to get my features done without impacting the performance of my customers. That is what an architect has to decide and design when he is designing a system. It is not just like you have to draw the box, you have to consider all those things. This is very, very, very much important. Second, auto scaling policy. Because let's say I'm anticipating more requests are going to come. Okay, so if I'm anticipating, let's say in general, I am having 5 pods, I'm anticipating more requests can come. I can have like 7 pods as a buffer, and then more pods I can leave for an auto scaling and having, let's say, threshold of 40% or 50%. That is going to work. And auto scaling is going to upscale and downscale automatically, and that is perfectly fine. I just can't say like, okay, without having an auto scaling switch off, I'm having 5 pods and I'm going to directly just keep like 10 pods or 15 pods. If those many requests I'm not going to get, or at that moment I'm not going to get, I need to pay it for every minute, every hour. That is what the auto scaling helps. Performance testing. By doing a performance testing, I would be having a proper metric how my system is performing, how much load it can handle, and how much pods or infrastructure is particularly needed. Then metrics to optimize resources and everything. So all those things are there which I wanted to bring in front of you when it comes from scalability. Again, like, this is purely coming from the experience that I'm having. I have worked, I have designed the system. All those factors are there. That is very much important for you to consider. In interviews, we generally see like we are saying, hey, we need to build a scalable system, but in real world systems you have to consider all these factors. And in future videos we would be discussing on other NFRs. Thanks.